Good morning. So my name is Danilo. I'm technical evangelist in AWS. And people that knows me, I'm very excited by serverless technology and how fast you can create something new. But I think that it's, especially for some kind of application, simple application, data-driven application, is still too complex. And the reason why it's complex is probably the way we build APIs. So normally, we use APIs with multiple endpoints, like with the REST model. So you have like the title, an endpoint for the title of the book, an endpoint for the author of the book. And I think this approach works well if you don't need to access cross data. So if you don't need to search for data that maybe is in two different categories. I want to search maybe a book and an author and something more complex than a simple point access. And that's where GraphQL can help. So with GraphQL, it's an open specification. It has nothing to do with graph databases. You can use any kind of database to store the data. You can even use transport different than HTTP if you want. With GraphQL, you have a single endpoint for your APIs, and then you can use a syntax that is much more powerful, because you can start by defining a schema. So for example, if you want to build the classical to-do application, you can create a type of to-do. The exclamation mark means that this field is mandatory and the other are optional. And then you can say, I want to query the to-do list. I want to get the list of to-dos so I can create my prototype queries. And then when the client is running the query, is using a syntax like this and can specify which kind of data that can be a subset of the old data the query must return. So when you need to create a list on a website, you don't need to get all the fields that you don't use. You only get the minimum amount of data that you need to build your user interface. And technically, the first layer when you want to use GraphQL is to design the schema. So let's say that we want to build an application that can track events and comment on top of these events. So events like this JeffConf. So we can create a type event that has an ID, a name, a location, a description. And this event is linked. So you see that we can create relationship now to comments. And the comment can have a content and a creation date. And then we can start to say, how can I change this data? So you can, it's what we call mutations with GraphQL. So I want to create a mutation for creating a new event, for deleting an event, maybe to add a comment on an event. And then you can specify how you want to query your data. So I want to be able to get an event by ID, or I want to get a list of events, maybe with some pagination. Building pagination in API is one of the most boring things that we built and built again and again. And most recently, GraphQL also added real-time subscription. So you can say, I want to be notified in real time every time someone is writing a comment on an event, because maybe I want to use this content in my application. And this is almost impossible to build with traditional HTTP architecture. You need to use other protocols or WebSockets and stuff like that. So now that we have all of this, we can see that with GraphQL, actually, we can do lots of things. We can do real-time and batch application. We can manage relations in our data. We can search. We can even manage offline access in our data. That's why we introduce a new service that is currently in preview. It's called AWS AppSync. That is a fully managed GraphQL interface for your application. So you can start by uploading your GraphQL schema, similar to what we just saw. And then AppSync can map this operation, so the query and the mutation and the subscriptions, to operations to a DynamoDB table. DynamoDB is a NoSQL database. Or you can call a Lambda function. So the query or the mutation that you receive can be mapped to anything. So if you have a legacy system, you can use this Lambda function to wrap with GraphQL any legacy system that has a standard interface you can call from a Lambda function. Or you can use a store and retrieve data from Elasticsearch. So it's good to build, for example, complex queries on top of your data. And then the client can connect using GraphQL and run the query, the mutation on the data that is mapped to the DynamoDB table or the Lambda functions, for example. And it can also ask for subscriptions, so that every time someone is, for example, changing some data in a DynamoDB table or calling a Lambda function, you receive, as a client, the communication in real time. We use WebSockets to do that. And if you don't want to write your own user registration again and again, we can use tools like Cognito to manage your user base, or you can use API keys if you prefer. And then you can still continue to add your own event-driven logic to this architecture. For example, you can create a Lambda function that listens to all the changes to the DynamoDB table and then can apply your business logic. For example, a common practice is to take the changes to the DynamoDB tables and write the changes to an Elasticsearch engine. So you can have your query and mutation that go on a item level. The simple ones go to DynamoDB, and then if you have a complex search, you can direct on the same data on Elasticsearch. And more recently, we added auto-generation of the schema. So if you're not a GraphQL expert, you can start from a DynamoDB table, and we will auto-generate all the standard query, mutation, and subscriptions for you so that you can start very quickly. So let's see a quick demo. I got time. Yeah. So let's start with a quick demo of what we're seeing. So this is the mobile app. I'm running the mobile app on a couple of browsers here. I have one browser here and another browser here. This is a standard web React application running locally, but it's then calling AppSync to manage the data. And it's doing exactly the same thing we were seeing before in the event and comment schema. So I can create events and I can comment on them. And if you remember, we were creating a single subscription here. It was on comment on event. So every time I add a comment, all the clients will receive the notification in real time that I'm changing a comment. So let's start here. I can create a new event. This is JeffConf, where it's in Hamburg. Description, a nice conference, I think. And now I have the event. So there's no real-time subscription for events, so I need to reload here. And I see now the change also in the other browser. And this is baked on a DynamoDB table. But now I can start to add comments. And comments will work in real time. So here, I click here and I say, hey, I like the initial keynote. And I click here. And then this is going to the I didn't click on comments here. So I have the comment here, and then I can add an answer here, and then I click comment, and this is sent to the other window, and here I can add my other reply, and this is sent in real time to the other window. So all this real-time subscription is managed by the SDK that we provide that goes on top of a standard open source client, the Apollo GraphQL client. So basically, the code in these two applications there on GitHub, you can have a look afterwards, are very simple because they manage mostly everything through the GraphQL endpoint. And they also work with offline support. So you have real-time communication. But for example, now I can try to disable the network in my computer. So now I have no network. And I can go here, and I can go back to events. And I want to, sorry for that, delete JeffConf. That was also badly written. And now if I connect the network again, this first one will recognize that this network, will synchronize the data. And now if I go back to events, there's no event. In fact, it has disappeared also in the other window. No event at all. So you have real-time and offline support out of the box. And I think this is already nice. So if we go to the AppSync, this is the AppSync window. So this is the console. We can, for example, this is the AppSync console, create a new API. And this is my live demo API. And I can use a custom schema. If you use the sample schema, you will get exactly the same application I was showing to you, so you can reproduce this very quickly. And let's say I'm not very good with GraphQL, so I want to start with a table that I already have. So this is some data that I have on DynamoDB. This is a books table where I have the books that me and Paul have written. So this is Paul's first book. It was published in 2017. It has a price, an ISBN, and other information. So this is written on DynamoDB. I can now go on the AppSync console, and I can say, create a new data source for my API. And this is a books table. I can choose the data source type. So for example, I can connect, as I said, a Lambda function, an Elasticsearch domain, or a DynamoDB table. So let's go for a DynamoDB table. It's in the same region, and I have this books table. Now I can click here and say automatically generate GraphQL, and everything is automatically generated for me. DynamoDB is a NoSQL database with a flexible schema. That means that we don't know all the attributes, the fields that you use. So we can only infer the attributes that are in the primary key or in any index. But then you can add the other ones here. For example, I also want to have a price that is a float number. And I also want to know the year of publication, that it's an integer. And then we have all the query, the mutation to get the book by primary key, the ISBN, to list the book with pagination, to query the books, create new books. Everything is automatically generated. I can now create this data source, and I can go back here on the schema. I have the schema. And when you use the schema, you can basically connect operations to these data sources. So for example, if I go in here in the query section, get book is connected to the books table through this adapter that I just created. And if you want, you can even connect a single field here. So for example, let's say that I want to show a different price depending on other parameters. I can attach the price here to a Lambda function and say this is not something that is on the database, but every time it must be computed using a Lambda function. And the Lambda function can be invoked every time or in batch. So if you have a query that is manipulating lots of data, we can support a single batch operation that will have a single invocation and manipulate all the data. In this case, you can really create fine-grained control on how the attributes are shown to the users. So let's see how you can use this data. So let's try to write a GraphQL query here. So for example, I want to list my books, and I want to get the items, and since there was some pagination, we also accept an X token. And now I'm querying. This is automatically translated to the query to the database, and I get the result back in a JSON structure. So those are all the books. If I want to use pagination, I can just add a first parameter. So I want to get only the first two. And now I get two books at the time, and then I have a next token that I can use to paginate my API. I don't need to write this pagination again and again. And if I want to run more complex queries, we auto-generated a query for every index that is already on the database, but you can add more. But for example, there should be like query books by author and title index. And here, of course, I need to provide an author. So let's see Paul's books. And again, I want to get the items and the next token because pagination is built in. And these are the books. Of course, maybe I don't need the author again because I'm querying by author. So I can remove here the fields that I don't need. I don't need the author. Maybe I don't need the price because I just want to visualize in my web interface the title and the year. I can just run this query, and I'm optimizing the bandwidth. So if this is a mobile application, I can only really download the subset of data that I need, not everything that is part of the records on the database. So another example, let's see this legacy app here. This is another API that I built. And in this case, I'm using a data source that is a Lambda function. In this case, I'm not using a database, but I'm using a data function because I can imagine that I have a legacy application that has any kind of interface, and I want to give a GraphQL interface to this legacy application. If we go to the Lambda console, this is my function. And the Lambda function is actually pretty small because I'm simulating, of course, the legacy application. But I'm just looking in the input event of the function. If there is a title, then I use the title. Otherwise, I create a fake title depending on the ID. And then I create a response that is the object that I expect is returned by the integration with the legacy system. So I suppose this is a trouble ticket that does an ID, a title, and a description. So you see it's just a few lines of code. So if we go back to the apps in console, you can see the queries here and the schema. And in the schema, I created a trouble ticket object that contains those fields. So you have an ID, a title, and a description. The description is optional because you don't have the exclamation mark. And then I want to query these trouble tickets by ID. And I want to be able, sorry for the zoom, to put a new trouble ticket if I want, giving a title. And here on the right, I connected these two activities, get and put, to a Lambda function. So if I click here, for example, I connect, when you connect a data source with a query or a mutation, you can use velocity templates. So this is the templated syntax that is used in the API gateway, but it's also the one from the Apache Velocity project. And these are completely auto-generated by the console. Basically, I'm saying take everything that is here and send it to the Lambda function, or take the Lambda function result and transform this into the input that, and the output of the operation. And now I can go on queries, and I can try to run queries through the Lambda function. So this query will not go to a DynamoDB table, will go to a Lambda function. For example, I can get a TT, so a trouble ticket. I can give an ID. Let's say that the ID is 123, so let's zoom a little bit. And this is called in the Lambda function, and I get the trouble ticket. Let's say that I want to know the title and the description, if any. And now I get the fake title that was generated by the Lambda function with a description, hello from Lambda. And I can change this with another TT, like 321. And since this is just a fake function, we'll just change the title dynamically because it was computed. You can also put a TT. So now I'm creating a new TT, and I can add a title. Let's go like this. No, there is not this right schema. I need to give a title. No, I'm using the wrong schema. Let me double check the schema here for the put. Yeah, it's the ID and the title. So maybe it's not a query, but it's a mutation. And now I can run the mutation to change the data. So now I can create new trouble tickets and change the ticket as much as I want. And this is updated by the Lambda function. So this is a completely different way of creating a serverless application, because if we go back here, you can use Lambda function, DynamoDB tables, and Elasticsearch as the container of the business logic of your application. It can be data-driven, or it can be in the Lambda function. You can still continue to create chains of events. So if you update the DynamoDB table, something happens and you process the creation of a new object on the database. And I think it's making the creation of a backend API for mobile or web application much, much easier to do. And I can see lots of use cases. So you can build real-time communication platform, real-time multiplayer games, even VR and AR, so augmented reality, where you need to synchronize virtual activities with data-driven synchronization can be implemented very, very quickly. And I'm really looking forward to see what you're going to build with these applications and with these tools. Thank you.